First question. Ray of light in air is incident on a glass surface. The angle of incidence is less than the critical angle. We know that when a ray travels from less dense medium to higher dense medium, total internal reflection never occurs, even though the angle of incidence is less than the critical angle. Greater than or less than anything, refraction happens definitely. Refraction occurs and partial reflection also occurs. Then partially reflected and partially transmitted. Partially transmit means refraction. The second answer, look at the second answer, refracted away from the normal. When it is traveling from air to glass, it does not refract away from the normal. Total internal reflection, no. It is not equal to, it is not greater than the critical angle. Even though it is greater than the critical angle, it won't happen. TIR will not happen because it is traveling from air to glass. Less dense to dense. Transmitted along the normal. Along the normal means going like this. It is wrong. Then answer A. There is an increase in the intensity of light incident on light dependent resistor, LDR. In LDR, this is a LDR. When light intensity increase the intensity of light, then this causes change in number of conduction electrons. Then conduction electrons, number of conduction electrons increases. Therefore, resistance decreases. When the number of conduction electron increase, resistance decreases. This is the answer. An electron has a de Broglie wavelength of 3.5 into 10 to the power of minus 10. Which of the following expressions gives the velocity? Then equation, direct forward question. Equation is de Broglie wavelength equals h over mv. mv is the momentum. Then we make velocity the subject. Velocity equals h over m lambda. Velocity, then h is 6.63 into 10 to the power of minus 34. It should be on top. Then answer is A or B. Bottom, mass into wavelength. Mass of the electron. Mass of an electron is 9.11 into 10 to the power of minus 34. It is given in the equation sheet. Then answer is A. Mass of electron multiplied by wavelength. Which of the following describes a change in energy of 1 electron volt? 1 electron volt is the energy associated with moving an electron with a voltage difference, potential difference of 1 volt, energy associated. Then a charge of 1 coulomb accelerated across potential difference? No, wrong. Charge of 1 coulomb pass a point in a time 1 second, wrong. An electron is accelerated across a potential difference of 1 volt. Yeah, this is the equation. Electron is accelerated across a potential difference of 1 volt. Change in energy. Change in energy is actually when the electron is accelerating from rest or any velocity, it gains a kinetic energy of 1 electron volt when it is traveling across a potential difference of 1 volt. Energy, then that's why I told that energy associated in moving an electron from one point to another point which has a difference of 1 volt. Then this is the only answer we can consider. Easily we can cross out these answers because 1 coulomb here, 1 coulomb here, 1 ampere here. They don't talk about electron, easily we can select the answer. The diagram shows 1.5 volt cell in a circuit with 2 resistors. The cell has negligible internal resistance. 2 resistors are given like this. The switch is closed. When the switch is closed, what will happen? The 5 ohm resistor will be short circuited. The current doesn't pass through the 5 ohm resistor, the current pass through this one. The current find the lowest resistance path. Then resistance here we consider that resistance of a switch is 0. Therefore, current passes through this way. Then this resistance should be neglected because no current passes through the resistor. The switch is closed. What is the reading on the voltmeter? Then the cell has negligible internal resistance. Then total voltage will be across 10 ohm. Therefore, answer is 1.5. A uniform wire is attached to a metal rule. The wire is connected in a circuit as shown. The distance d between the connection to the voltmeter increases. The reading V on the voltmeter changes. Yeah, distance measured from this way when the the negative side is connected to this, positive side of the battery connected to this. Right. Say the voltage is E. Okay, it's better we take a number. Say 6 volt battery. Then the idea of 6 volt mean here negative side 0 volt, positive side 6 volt. Then this side the voltage is 0 volt. This side 6. Okay, let's see wire attached. The distance d between the connection to the voltmeter is increased. The reading V on the voltmeter. The uniform wire is attached here. This is the wire. Actually, they don't mention the wire. This is the wire. Okay. Then when this terminal is here, no potential difference because negative end is in 0, positive end also in 0. Negative end is on 0, positive end also on 0. But when positive end is moved towards right, this wire has a resistance, then V equals IR, this side 0 volt, this side 6 volt. Maximum potential is 6 volt. Current remains the same here. Current doesn't change. Voltmeter change because current doesn't flow through voltmeter. Therefore, current doesn't change when you move the terminals. Current doesn't change. But resistance increases. Therefore, voltage increases. Voltage increases from 0 to 6 volt. And we can use another equation, R equals rho L over A. R equals rho L over A means R is proportional to L. No need to get these equations because we have only one option in the answer. It is not started from 0, negative value. It is starting from 0. I told that when the positive terminal is on the negative terminal, voltmeter reading is 0. Starting from 0, and only one graph we have like that, starting from 0. And if curves are there, we have to consider these equations at R is proportional to N. R is proportional to L means R is proportional to voltage. Therefore, R is proportional to voltmeter reading is proportional to length. From here we can take. But no need to consider these equations. Directly we can find the answer, since we don't have curves. Microphone is attached to an oscilloscope. The microphone is detects a sound. The trace displays on the oscilloscope screen given below. One division is 0.015. One division is 0.015. This is a cathode ray oscilloscope. And one division, actually we call it time division, actually time base setting, but it is not given like that. Easily we can get that. Time of one division is 0.015. Time of one division is 0.015. Then how many divisions are there? 1, 2, 3, 4. 4 divisions in one cycle. One cycle of the wave, time taken is 0.015 multiplied by 4. It is the period. Then frequency is equal to 1 over this one, 0.015 multiplied by 4. F equals 1 over T is the equation we use. F equals 1 over T is the equation we use. The other one, time base setting multiplied by 4, because 4 squares, one cycle is 4 squares. We use that one, that theory. Then answer is D. At a distance d from a point source of light, the light intensity is I. Which of the following expression gives the light intensity at a distance 2d from the source? We don't know the power actually. Power is here. Power is emitting by a point source. The light is distributed all over like this. When we finding the intensity, we draw a circle like this. But this is not a circle. This is not a circle. This is a sphere. The area of a sphere, then say power produced by the source is P. Intensity at a distance d is given by intensity equals power divided by 4 pi d squared. Now, they are 2d away. Then I dash is equal to power is same 4 pi 2d squared. Then when you divide these two equations, it's clearly known that second equation is multiplied by 1/4, because 2d squared means 4d squared. Then you can divide and see if you can't understand. Then second one divide by first one, you can get P divided by 4 pi 4d squared, multiply, divide means multiply by reciprocal, 4 pi d squared. Then 4 pi cancel, p cancel, d squared cancel. Then this is actually I dash over, this is equal to I dash over I. I dash over I is equal to this one. Then I dash over I equals one over 4. Then I dash over I equals 1 over 4. Yeah, then when you take I to the other side, I divide by 4. I did this question using basic principles. We can do the same question using I is proportional to this square of 1 over square of distance. Yeah, after finishing the paper, I will discuss about this one using the proportionality, inverse proportionality. How do you do the question? 9th one, two polarizing filter X and Y arranged between a light source and observer like this. Two polarizing filters are there. The intensity of light reaching the observer is maximum. The observer rotates filter X. The observer then rotates filter Y so that the intensity of light is a maximum again. Yeah, light intensity is maximum. Light intensity is maximum, and then the observer rotates filter X. The observer then rotates filter Y so that intensity of light is maximum. Then when the light intensity is maximum, these polarizing filters are in same orientation. If vertical, if X is vertical, Y also vertical. If X is horizontal, Y also horizontal. But then X is rotated. The observer rotates filter X. This one is rotated, and then Y also rotated to get maximum again. When you rotate X, the light intensity decreases because these two are not in the same orientation. For an example, say observer rotate X this way. It is not given actually, not given the orientation, angle. Now the light intensity reduces because these two are not in the same orientation. Which row of the table shows possible angles of rotation for the filters? Then angle X is rotated by 90 degrees. If the angle X is rotated 90 degrees, that means vertical become horizontal. When vertical become horizontal, this also you have to rotate by 90 degrees, or you have to rotate 270 degrees. I think you understood that. This one is rotated by 90 degrees. This one can be rotated 90 degrees, same angle, or 270 degrees in the other side. Other side 270 is equal to, it's like this. If this is 0, you go to 90, or it is similar to 270 in the other way around, rotated. 90 and other one 180 not possible. 180, one is rotated 180, the other must be rotated 180. Because when you rotate, let's say this one, the orientation, if you rotate 90 degrees, it would be like this. If you rotate 180, it would be like same. Then the other one also was same orientation, then the other one also should be rotated 180 definitely. This one is correct. 270 and 90 possible to get the correct way. Definitely you get the correct way. not possible. This definitely you get. Because you rotate 90 degrees this way and the other way 270, then you get the same orientation. See. In an atom, an electron drops from energy level E2 to energy level E1, E2 to E1 as shown. Photon of wavelength lambda is emitted. Which of the following expressions give the energy E2? This energy level E2, energy released is HF. HF can be written as HC over lambda, because F is frequency, frequency equals speed of light divided by wavelength, HC over lambda. Then this energy must be less than E2 by this amount. It's an easy question. E2 minus, okay, we have to find E2. Then E2 minus HC over lambda is equal to E1. E2 minus HC over lambda is equal to E1. Then E2 equals E1 plus HC over lambda. Then the answer D. I promise you to explain the 8th question again using another method. Here look at this. We get I dash equals 1/4 I. That means I over 4 should be the answer. Then inversely proportional method. We use inversely proportional method. When the distance D, intensity is I. When the distance 2D, intensity I dash. The relationship is intensity is inversely proportional to D squared. Then I have to square this one, D squared. Inversely, if something is inversely proportional, we multiply like this, direct multiply. If something is directly proportional, cross multiplication we use. Then this is inversely proportional, they multiply. I multiply by D squared is equal to I dash multiply 2D squared. This is easier than the method I did earlier, because I wanted to explain from the basics, but you can use this method as well. Then I dash is equal, sorry, here I did a mistake here, 2D whole thing squared. Then I dash into 4D squared is equal to I into D squared. D squared to D squared cancel. I dash equals I over 4.